to the cloud. And here we go with this. Continue, continue, continue. All right. So we will learn today, we're going to learn all about exponential functions to include key features. So like, from a graph, that type of thing. All right. Now, asymptote is our first vocabulary term. Okay. This is a line that a graph approaches but never ever touches. Oh, thank you for letting me know, ma'am. All right. So let's go ahead and let's look at this. A line that a graph approaches but never ever touches, okay? And so basically if I have a coordinate grid like this, right? And let's say that I've got, now when we look at exponential, we're going to have two different types of exponential equations. And one of them is going to look like this. This is called exponential decay. And it goes down really fast, and then it kind of gets a little bit like this, right? Well, here, right here, let's say this is the line that it never, ever gets below, right? And this is on the y-axis. Let's say that this value is 5. So our equation is going to be y equals 5, okay? And that would be our asymptote, y equals 5, okay? So let's go ahead here. Exponential function is a function.
I lost something, so.
Oh, no.
I left it in the room.
Okay. A function that can be described by an equation of the form, and this is important, so I'm going to put in a different color, y equals a to the power of x. Well, I was going to do it in a different color. I can do it in a different color. Y equals a to the power of x. So notice for the first time, x is in the exponent, okay? But there are two rules. Number one, where a being the base, right? Where a can, a's got to be a positive number. That means greater than 0, right? And a cannot be equal to 1. Okay, so two rules. A has to be positive, and a must never, ever be equal to 1. Okay, so can you think of maybe this past year when you've heard of exponential growth? Wow, that's growing exponentially, like on the news. Can y'all think of anything? No? Anybody ever heard of, like, I don't know, COVID? Didn't they talk about, like, yeah, like in the beginning it was like, oh, just a few, and then pow, you're home, right? So you could have something like this, y to the power of 2 to the power of x. That's called exponential growth, right? Or we could even have something like this, 1 over 5 to the power of x, and that also would be considered an exponential function, all right? If I had something like this, y equals 2x plus 1, what is that? Yoo-hoo, linear, okay? And if I wanted it to be, these are my counter examples, right? So if it's quadratic, I can just change one thing. What is that one thing I can change to this equation? The x squared, beautiful, okay? So all you have to have is the exponent of 2, and now, ta-da, it is quadratic. So these are my counter examples. Guess what? These are linear and quadratic. They are not exponential, okay? And so, yeah, there has been a lot of talk, and usually whenever they talk about viruses in general, they talk about exponential Yeah, Roman, you had it. Good. They talk about exponential growth, and there's times when we're going to talk about exponential decay. So what is exponential growth? Well, it's when an initial amount increases, not just like, oh, 5 more cases today, 5 more cases today. It's like 5 more cases today. Oh, 100 more cases today. Oh, that's like 1,000. And then it's everywhere, right? The same percent over a given period of time. Okay. All right. And so I like to try to draw a little picture here. If exponential growth might be like I plant a little seed today, right? Then tomorrow's like just a little leaflet, right? And then the next day it's like this, right? And then the next day with even more. And there. And then the next thing you got is like this huge plant. Yes? Huh? Yeah. No. Actually, this is one of the few times I just wanted an illustration. Sorry about that. So it is actually like exponential growth. It kind of starts right here and then whoop, goes up, right? So that's the shape that's going to take. And it's when it goes like that. Starts off kind of slow and then okay. All right. Exponential decay. That's when you have an initial amount. Let me take away the U. Why? Sorry about that. When an initial amount decreases by the same percent over a given period of time. Okay. And so like here, maybe something that we're doubling. Every day it doubles. We go from 5 to 10 to 20 to 40 to 80, right? That type of thing. Exponential decay with my little example here would be like, oh, what happened with the frost, right? When it snowed, I had this big, beautiful banana plant. Or it's actually not. Yeah, let's just say it was a banana plant for simplicity. Yeah, that's what it looked like. Not the best looking picture. And then it just kind of like looked like this, right? Died. And now it's like this, okay? And so essentially you had something beautiful just decay, and now it's just the earth, okay? It was very sad. So here we have something that looks like that. And it goes and decays, okay? So that's what it looks like. Questions? And granted, my pictures are not the best, but you got it. Okay, let's go ahead and let's look at example 1. All right, ladies and gentlemen, right here we have exponential growth where y is equal to 4 times x. This right here, this is what we call the base. And what do we call the x? Starts with an E. Exponent. Very nice. That's why we call it exponential. So the base, in order for it to be growth, must be greater than 1. Okay? Any number greater than 1. What I'm going to do, now most years we would do this all without the calculator, okay? But because we are trying to get everything in, we're just going to kind of make this go a little bit faster, guys, okay? So when I look at this, I'm going to put it in my calculator, y equals, and clear all this stuff out. Does everybody know how to get to y equal to put in? Okay, you got y equal. And I definitely recommend following along because, you try to do it and sometimes things always end up a little different. So we got 4 and then caret. Caret is right below the clear button. And then we have x. Any questions on how to enter that? And yet I still don't see calculators on everybody's screen. You will be missing out. I'm just letting you know. Okay. So I look at the table, second table, and I've got this stuff in there, right? So I've got like, those are really crazy small. I don't want too many small numbers. So I'm going to do -2, -1, 0, 1, 2. I'm going to throw one more in, 3. Okay. And so I've got something that looks like this, 0.0625. And I have 0.25, 1, 4, 16. Am I doing it right? And then I got 16 before. Yeah, I think I am. Okay. And so we're just going to kind of graph this. Okay, I'm going to go ahead and put in my points. And I have a point at -2 and some crazy small number. About right here. Okay. -1 and a slightly larger number. And I can make it bigger if you like. And then we got 0, 1. Okay, and I have 1, 4. And then I have 2, 16. And that's like not even on here. So I'm just going to put it right there. So it looks like, and if I look at the picture, I kind of got something that looks like that, right? So what happens is that it kind of starts off like this, right? It's super, super close, but I will tell you, it never quite touches, right? It's super, super, and gets slightly bigger, slightly bigger, slightly bigger, and then it just takes off. Just takes off. And we're going to pretend that that's a nice straight line. Okay. So let's talk about the y-intercept and all that kind of stuff, right? Let me talk to Aaron. What is the y-intercept for this particular? And let me know if you need a hint.
1.
He says 1. Okay, where do I put the 1 in here?
On the right side.
On the right side. And what's going to be here on the left side?
Okay.
Which is? What is he telling you?
0.
0. Okay. So if you look at it, right, this point right here, and sometimes you just need to see it from the table. Whenever x is equal to 0, that's your y-intercept. You need to memorize that, okay? And this right here is your coordinate point. And of course, this right here is what it looks like. It's where it actually touches the y-axis. That is your y-intercept. I don't know if you can see my writing very well, but there you go, okay? That's the y-intercept, boys and girls, all right? So we're going to talk also about domain on this one. Domain. So let's see. Let me talk to Alexa. Tell me what you know about domain, dear. And let me know if you need a hint. It's all about X from Dixie Royd, right? And we know domain, that's D for domain, is all about X. So we can go ahead and start right here. Boop, boop, like that, right? I don't see any open dots. And do you know anything else about it, or that tapped you out? That's it. That's all we know. Okay. So you said it's all about X, right? So that's the X axis. Does it go up and down or left and right? Left and right. Very good. So what we want to do is we want to kind of go like this. We want to go all the way from the left. And then we want to go all the way to the right. Right? Something like that. And I wish my lines were straighter, but they're not. Okay. And then the other thing is on my little blue one. Now the calculator won't draw arrows, but you know there's a little arrow right there. Okay. So my question is, Alexa, is this going to be -10 for my little value, or is it -infinity? Because it keeps going, because it has an arrow, right? So we know it's going to cross my little green line, right? So that is entirely -infinity. Okay, good. Now on the big side right up here, is this going to be 2, or does the arrow cross my green line? It does. And so instead of 2, I'm going to put +infinity. Good. All right. And you can pass this along to somebody else if you don't know. But what's a three-word phrase that basically means this? Because this is not the option you're going to see on the test. There you go. See, you know a lot more than you thought. All real numbers. Good job. Ladies and gentlemen, this is my domain. Yes? All right. Not as, yeah, fancy R. There you go. That you probably won't see until like maybe algebra 2, maybe geometry, depending if they use it, okay? Probably not on your star. Let's see. Alexis, share with me what you know about range, sir. What do you know about range?
I'm trying to remember right now. I'm sorry.
Okay, well, let's look at Dixie Royd, right? So last time she said, well, we got domain. We know it's all about X, right?
Yeah.
So range is probably all about,
Range is Y, right?
yeah, because of the
Okay.
Y right there, right? So I'm going to put that
Yeah.
smack in the middle. Okay, I don't have any open dots, right? And then we put our little number on the left. And we're going to put our big number on the right.
Oh, okay.
Okay, so thoughts?
Do we put the 0 on the left and the 1 on the right?
I like 0 on the left.
Okay.
I do like that because that is my lowest right here.
Okay. Yeah.
Okay. I do got one little thing about that. Remember how we said this is also my asymptote, yes? So does it ever touch 0?
I don't know.
And how we can tell is like, look at my table, right?
Yeah.
Do you see any negative? I mean, we got these funky numbers, but that's like scientific notation, right? And all that means is that these numbers are crazy, crazy small, but you don't see a negative in front of any of them. So it gets super, super, super duper close, but it never, ever gets to 0. So I am going to change one thing about my inequality. Do you know what it is?
You're going to change the 0, right?
No, I'm going to change this. I'm going to take off the equal.
Oh.
Yaha. Wow. Ah, sneaky. So I got the 0. I like the 0, but I'm just going to say y's got to be anything greater than 0. That way it doesn't actually include 0, right?
Yeah.
Okay, so now let's look at our high value, right? So I want to make sure we're kind of like looking at that blue line, and my biggest value is like way up here. But guess what? It hits that arrow. So what does that mean?
It goes. I'm not too sure. I'm sorry.
Okay, so last time when we talked about domain, right? That's the green part, right? We had a little arrow, so we said, oh, that's negative infinity. And then over here, we had an arrow, and we said, oh, that's positive infinity because it's going to cross it, right?
Yeah.
The whole idea is if it crosses the line, then it's probably, and it has an arrow, then it's going to be infinity. So here on this low one with the purple, I mean, there is an arrow, but it's never going to cross the purple line. That's why we actually put it at 0. Here, does this blue line, is it going to cross the purple line?
I don't know. I don't think it will.
Yeah, it is. Because look at the y's. Let's go. Okay. So we're at 1, right? And 1, you got 4. Okay. Well, that's definitely higher than 4, right? Then the next one, 16. Is that the biggest number?
I believe so.
Nope. There's 64.
Oh.
You see it? Is 64 the biggest number?
Yes.
Let's see. No, 256 is the biggest number.
Oh. Wait, so is it going to be infinity?
Yeah. So this right here is positive. It goes on forever. I was just going to see how long it took. But we got positive infinity, right?
Yep.
All right. Thanks for playing with me. So, so basically, we're not going to include that infinity on the test, right? They're not going to include it. All right. One last question because you were so much fun, Conrad. Can you tell me, Alexis, sorry about that. Can you tell me, sir, like, how are they going to put it on the test? Do you know?
Is it just going to be 0 to y like that? I'm not too sure.
It's going to have a y and it's going to have a 0.
Mm-hmm.
And the sign's going to flip. Thank you, Samantha. She's like, come on already. All right. So see how it's pointing to 0? And we want it to point to 0. So that's basically it right there. That's what it's going to look like on the test. That's the option you want to pick. Amazing, huh?
Yes.
Yeah. Awesome. Thank you. You've been fun. All right. So Aubrey, after that, go ahead and share with me the equation for the asymptote. What is the line, the equation for that purple line that it never quite touches? And let me know if you need a hint. It's okay if you need a hint. Okay, let's talk about some Hoy and some Vux. Okay. Do you remember Hoy and Vux by any chance? Be honest, that tells me no. Okay, so this is horizontal and this is vertical. Okay, what this is saying, I got a 0 slope, and if you didn't know this, you should write it down, and you've got an undefined slope. That's where he falls to his death and he screams undefined, right? And so here he has x equals, and that's going to be some sort of number wherever it hits the x-axis. And your equation here is y equals, and it's going to be some number wherever it hits the y-axis, right? So this purple line, Aubrey, is that going to be horizontal or vertical? Horizontal, I agree with you. And that means my equation is going to be y equals, and where does it hit on the y-axis? Do you need me to make it bigger? Okay, making it bigger. Okay, that's 1. This is 0. So, yeah, it's kind of hard to see, but it's basically an equation where y equals 0. Yes? Now, our examples today kind of show y equals 0, but it could be like in our example that I gave you earlier where it's y equals 5, right? It's a horizontal line. It is going to be y equals. All right, good. Thank you. All right, next one. Example 2. Okay, so please note if you're looking at the little paper, it got kind of cut off. The equation is on the very bottom, and then all the stuff that goes with it is on the next page. We're going to pause right here, and you're going to go ahead and fill in as much information. I'm going to give you 3 minutes. So of the things that I saw, one of the things that students had some issues with was number 1, entering it, right? And so it's going to be y equals to enter your equation. Parenthesis, alpha y equals 1, and then you got 1 over 4. And then to the right, you put your parenthesis, and then this caret will give you the exponent, and you can type in your x that way, okay? So that's how you do that. And then you go ahead and hit second graph to get your table. And the other observation that I had was a lot of students were like, wow, these are really hard to graph, Miss. So if we move up, we can kind of see numbers that are a little bit easier to graph, okay? So when we do that, we go ahead and I'm going to go ahead here, and I'm just going to 64 maybe a little tough, but you know, whatever. Let me put it in -3, -2, -1, 0, 1, 2, toss in a little extra, right? And then we're looking at 64, some huge numbers, 16, 4, 1, and like 1/4, and then 1/16, okay? So when I look at this, and I kind of also want to look at my graph and kind of see, okay, I also see it never really crosses the, x-axis, right? So it never drops below 0. So I'm looking at a couple of things. Number 1, the fact that it never drops below 0 means that my equation for my asymptote is what? Anybody know? If it never ever touches this line right here, y equals 0, okay? Because it's a horizontal line and it hits 0, right? Just a thought. All right, let me go ahead and let me plot some points. So I'm going to put in -3, 64. That's like huge. And then -2, 16. Okay, that's really big too. And then I got -1, 4. And I got 0, 1. Ooh, that's a special one. What is that? Kind of, that is a y-intercept, right? So automatically I can just go, oh, 0, 1. By the way, if the question says what's the y-intercept and it only asks for one number, you could put in just 1, okay? But if it asks for an ordered pair, put it as an ordered pair. Either way. You got 1 and 1/4, so that looks like that. That looks exactly 1/4. And then you got 2 and like even less than that, 1/16. And so you're looking at something like super huge, going like all the way down, but never ever quite touching. We just can't see. Yes? All right, domain. Let me talk to Clinton. What did you get for your domain, sir? You haven't gotten to that part? Okay, well, tell me what you do know about domain. Domain is all about what? Yes, from Dixie, right? Got the X. And the X-axis goes up, down, or left, right? Left and right. So we're looking on the X-axis for my smallest value. And we're looking for the biggest value. Now, if it crosses my green line, then it's infinity. If it doesn't, then it's the number it's at, right? So what do you think for the little number? Are we looking at -infinity or -2, sir? I agree, because it's going to cross that -2. Okay, and on the big side, what am I going to put? Actually, this is where the positive numbers live, but I like infinity. Yeah. And so how would you say that?
All in.
Yes, sir. Very good.
Is there a line underneath the inequalities?
Is there a line? Oh, you know what? There should be, except that my drawing's getting so sloppy. There we go. Thank you. And this is positive, and then let me try and do a nice infinity looking thing there. Okay. All real numbers. Say it again. And it's the fancy R. Like that. Very nice. Okay, range. Let's talk to Jamila. Thoughts on the range?
Well, the range
Yeah, what do you know about the range?
is the lowest number on the line, right?
Okay, we're going from low to high. I like that. So here's my low, and here's my high. Okay, range is all about which variable, madam?
Y.
Y. What's my low? What's my high? And let me know if you need a hint.
Oh, I think I need a hint.
Okay, so when we look at the low, we're looking at this red line, right? Or this magenta line. And we're saying, like, is it going to ever cross this blue line? Does it ever cross the y equals 0?
Can you repeat that? My iPad's kind of lagging. Like,
Okay, you see this function line right here? Is it going to ever cross your blue line? Is it ever going to get lower than 0?
no.
No, and it's never going to get to 0, right? So we just put in 0 and then take off that equal, right? Because it's never ever going to get to 0. Why don't we put negative infinity? Because it has to cross the line. Like, see here with like this other blue line, right? Is the line going to cross the blue line? Yes. So that's positive infinity, right? But here, does it ever cross that blue line down below? No. In fact, does it ever reach y equals 0? No, it just gets to be these really small numbers. So it's anything that's slightly bigger than 0, right? So that's why when we write our final answer, it's just going to be y is greater than 0. It's all things greater than 0, but it does not include 0. And it might be 0.000001, but it's never going to get to 0. Okay. Okay, because your little number goes on the left and your big number goes on the right. And so our little numbers on the y-axis live below and our big numbers live on top. Does that help? Okay, good. And so that's how you do that one, okay? Now, I'm curious because I'm starting to think this is not a thing anymore. How many people want to get a car when they're 16? Okay. How many people think they're going to get a car when they're 16? Okay, so you're like, I may want it, but I'm not going to get it. Okay. So, well, y'all have had the most out of like all my classes. Most of the classes just like nothing. I'm just like, because I know quite a few people that are now like 21 and mom is still driving them everywhere. I know, right? And I don't know about y'all. I was 15 with a learner's permit. Let's go. Yeah. Okay. So if you want to get a car, guys, y'all need to know about depreciation. Okay. Your car is the worst place to put your money. You buy a car, you drive it off the lot, you just lost money. Just know that. Okay. They're essential, they're fun, but worst place to put your money because you're going to lose money. Okay. So here's the equation. This function v is equal to 25,000 times 0.82 to the power of t, right? And this models the depreciation of the value of a new car, brand new, right? That originally costed $25,000. That used to be a lot of money, unfortunately, now. Anyway, but V represents the value of a car and T represents the time in years from the time the car was purchased. So we want to graph it. We want to find what values of V and T are meaningful in this function. All right, so if I'm going to take this and I'm going to put it in my calculator. Let's see. Michaela, how am I going to put it in my calculator? Y equals, right? Clear all that stuff. And what do I type in? Do I include the commas? No, please don't. Okay. What does this little dot mean? Times multiplication. And then we got 0.82 to the power of what? Calculator does not like T, boys and girls. X. Okay. So maybe even without you realizing, y'all replaced a couple of variables. Okay. First of all, you replaced the variable V with Y1, didn't you? And then you also took T and you told me that that was X. Yes? So without even realizing it, you're telling me that X is actually T for time in years. And then Y is the value of the car. And what unit is that in? Because this time is in years. That's my unit. Money. Money in yen? In dollars, US dollars, right? Okay. So I'm going to go ahead. I'm going to pull that up in my table. Now, we got a lot of stuff that mathematically makes sense, but when we start talking about word problems, they don't make sense in word problems, right? Javi, can you tell me something in this table right here that just doesn't make sense for this particular problem? The negatives, right? The negative X, because X is in time, right? So how am I going to have a car that's negative 3 years old if it was brand new this year in 0? Right? That can't happen. They weren't holding on to that car like, no, that car wasn't even built. Yes? So that doesn't make any sense to have negative. So I'm going to make that little note right here. Okay? So in this particular problem, it is not reasonable for me to write in a straight line to have X being less than 0, right? Because it's a new car. So just kind of know that, and each problem is a little bit different, right? Huh? Am I still recording? Yes, I am. All right, so here we go. We're going to have our graph. We're going to have this. Let's go to our table. I don't care about the negatives. They don't make sense. We're going to start off at 0, 25,000. So here we got 0, we got 25,000. We got 1, we got 20,500. That car dropped in value $4,500. And you know how they say as soon as you drive that car off the parking lot, you just lost a bunch of money? Absolutely true. Absolutely true. Because if you're going to spend the money on a brand new car, and somebody says, well, you can buy mine for the same price, but I only put about 10 miles on it. You want the 0, right? If they're going to have, actually, you know, they do that with like the ones that they let people drive. They sell them at a discount because once you put any miles on it, it's already lost value. All right, so here we have 2, 16,810, 3, 13,000. And this is where people end up in a situation, especially when they start making they get a loan for like 10 years. I don't even know if they have 10 years, but you know, something ridiculous like 10 years on a car. And they end up owing more money than the car they could even sell it for. You know, it kind of gets to that point. So it's real easy to go what they call under. Okay. So here we go, where you're upside down. So here you got the car just goes down. Let me go ahead here. Trust me on this because we're kind of running out of time. This is 5,000, 5K. I'll make this one 10K. K stands for 1,000, y'all, in case you didn't know. 15K, 20K, 25K. So that car is initially worth $25,000. Y'all don't even want to know how much my first car was actually worth. It was nowhere near $25,000. All right. And then after 1 year, that car was only worth about $20,500. That looks like $20,500 exactly. And then the second year, $16,810. 3. And you got 13. Oh, it's like, yeah, it's all right. It's around here. Around here somewhere. And then year 4, you got 11.3. You got something like that, right? And you know what? I'm just going to go out a few years. Let's see. After 10 years, how much is that car worth? That $25,000 car? Oh, right above $3,000, which was right about the price of my first car. I had it right after they used it all up. And after that, shortly after, they pretty much just sell it for parts, I think. Okay, so you have something like that. No, it's not the best parabola, but you get the idea. So is this decay or growth? Decay. Excellent. What's my y-intercept? There you go, $25,000. That's the beginning of our story, right? Our domain. Let me talk to Maria. What do you know about domain, man? All about x, right? What's my smallest value? So we're on the x-axis, right? We go from left to right. And so I got to be honest here. We said it stopped here, right? Does it stop here at 10 years? No, it keeps going. Okay, guys, I'm going to wrap this up. We're looking here. Basically, the lowest value for our domain is 0 years, right? But it can go on forever, technically, I guess, right? But let's look at this. X is greater than or equal to 0 is our domain, right? Our range is going to be from bottom. And the lowest value for this car, if I look over here, wait, hold on, y'all. Look, we get down to $50 for this car, right? Do I ever get to a negative value? No. So that means that basically we got a lowest of 0 and a high of 25K. So you have a range of 0 and 25,000 right here, right? One more 0. Okay, that's an actual answer. And your equation for your asymptote is y equals? 0. And we're done. Y'all have a nice day, guys. All right.